Good morning, participants. Uh, our today's expert is about to come, so we will wait for 5 more minutes and then we'll start with the session.
गुड मॉर्निंग सर, गुड मॉर्निंग।
नहीं आए क्या, यही देखें आए क्या देखें,
पूछो ना, नाम लेके पूछो ना।
गुड मॉर्निंग सर। सर
अभी दे
सर डॉक्टर परदासानी सर, सर हैव यू ज्वाइन? हाँ सर है।
गुड मॉर्निंग सर।
गुड मॉर्निंग सर।
अब इनको वो अनम्यूट करो, इनको पहले वो बना, हाँ, और अब इनको वो बना लो कोर्स।
Yes, good morning to all of you. Now you can hear me?
Okay, sir.
Okay.
So now we start with the program, sir.
Yes.
So good morning to all. Myself Navneet Kaur. It is a great pleasure for me to welcome Dr. Kamalraj Pardasani, the speaker of today's session. Dr. Kamalraj Pardasani is a professor in MA at IIT Bhopal. He has more than 36 years of teaching experience in both UG and PG. His specialization areas are computational and systems biology, bioinformatics, biomathematics, biocomputing, data warehousing and data mining, soft computing, finite element modeling, and law informatics. He has supervised 37 PhD theses in the field of mathematics, bioinformatics, computer applications, and mathematical computational biosciences. He has more than 200 publications in various reputed national and international journals and conferences. He is a chairman, work group on bioinformatics under Technical Committee 5 of International Federation of Information Processing, a UNESCO body on IT since May 2010. He is Executive Committee Member, Vijayan Parishad of India since 2004, Member of Academic Council, NITR Bhopal, Executive Committee Member of Indian Society for Industrial and Applied Mathematics, and also Executive Committee Member of Indian Society for Biomechanics. He is honored with Outstanding Young Person of Gwalior Award in 1997 for academic leadership and accomplishment by Gwalior Junior Chamber. He was also honored with Outstanding Young Person of the Zone 6 Award in 1997 for academic leadership and accomplishment by Indian Junior Chamber Zone 6. Also honored with Outstanding Young Person of India Award in 1997 for accomplishment by Indian Junior Chamber under the scheme of 10 Outstanding Young Persons of India. There are many more honors and achievements associated with him. It is my privilege to welcome you, sir, on behalf of EC Department of SIRT. Now I would request Dr. Kamalraj Pardasani to continue with his lecture. Sir, please, sir, over to you, sir.
Well, good morning to all of you, and thank you all the organizers, especially Dr. Navneet Kaur for giving my excellent introduction. Although I do not deserve that. Today I'll be talking on basically soft and fuzzy set based approaches for soft computing, because your uh, topic of the workshop is mainly the soft computing techniques. And I'll try to uh, explain various uncertainty handling approaches in this soft computing techniques, how they can be introduced into them and develop new algorithms. I will be more focusing on that. So first I'll start with the basics of some uncertainty modeling techniques which can be used to develop new algorithms for soft computing. Later on, I'll show you the application of this uncertainty handling in neural networks, somewhere in swarm optimization and some in data mining and so on. I'll try to put up some problems also before you. So first, I'd like to share my screen, and uh, I think the screen is visible to all of you.
Yes, sir. So it is visible.
It is visible. Okay, fine. You want that I should expand it a little bit? It can be done. Yes. So, or I can go for full
Slideshow, sir. Yes.
slideshow. All right. That's also I can do. I'll go for slideshow. It's not going. Yeah. So, soft and fuzzy set based approaches uh, for soft computing. So, basically, the question of AI or soft computing arises where we have to deal with the relationships, and many relationships are hidden relationships. So we use various tools to uncover these hidden relationships among the data sets or the attributes of the data sets. And so many times the phenomena which we want to understand, uh, it has its inbuilt vagueness due to some unreliable data or inadequate data or defective information or partially contradicting information and so on. So many things happen, and they lead to mm, um, different kinds of uncertainty, uh, and how to handle. So the traditional mathematical tools are not able to handle those uncertainties, and such problems do arise in economics, environment, biology. So I'll mostly be focusing on problems of biology because my most work is in that area. So the tools which are being used for modeling uncertainty are fuzzy set, rough set, weak set, soft sets, and a lot of their generalizations which are coming up very fast. So I begin with the fuzzy sets. Jade in 1965 gave this concept, and he characterized the fuzzy set as a by a membership function. So most of you are from computer science, so I don't have to discuss in detail about fuzzy sets, and you know about it. So main thing he gave was the membership function. So the traditional set or classical sets were not able to deal with this kind of uncertainty. For example, set was defined as a collection of well-defined objects, but if the objects are not well defined, then what happens? How to deal with them? So I say students of class 10, but I say all tall students of class 10, then how do I decide what is tall and what is short? So we define the membership of the tallness. So if the students are there, a height from having height from 5 feet to 6 feet, so a person with height 6 feet is tall, the membership will be 1, and the person with height 5 feet will be tall, the membership will be 0. And person with height 5.5 feet will be considered as tall, the membership will be 50%. He is 50% tall and 50% short. That way the membership grade was given. So he gave a grading here, and though so the set was consisting of pair of values, and this mu a was called as membership function, and it's also a characteristic function. So in a crisp set, the value of this membership function is either 0 or 1. But in fuzzy set, the value of this membership lies between 0 and 1. That means it can take any value between 0 and 1. Whereas crisp sets takes only two values, either 0 or 1. That means either element belongs to the set or does not belong to the set. Here, every member belongs to the set, but with some membership. And if membership is 0, that means it doesn't belong to the set. But if membership is 1, he is 100% member of the set. And if membership is 0.5, then he is 50% membership. So his degree of membership is 50%, and so on. So this concept was given by Fuzzy Jade in 1960s, and he took 5 years to publish this paper. And he first submitted the paper in one journal. It was rejected again. And it came back in 2 years. At that time, it used to take very long because everything went by postage. And then again, he submitted in another journal. It was again rejected. So it took 4 years, and again then he became a member of editorial board of one journal, and then he submitted this paper and he got this paper published. So he managed to publish this paper. That way people say. But the thing is not he managed. The important thing is the moral of the story, that how much confidence he had in his concept, that he has to wait for 5 years, and he has the determination to bring this concept to the world. And that was his determination which made him to get the paper published. So we today we look for publishing a paper in a good journal and it is rejected multiple times. That doesn't mean that our paper, our idea is, it is bad. It may be that the board is not convinced by our idea, and you need a determination to convince the people. So whenever you come out with an idea or any concept, you have to do the marketing of that. That means you have to be determined to sell it in the market. You have to keep patience that once the people are convinced, it will be accepted by the world. So that is the idea behind it. So this is what is the important thing in research. We need a lot of patience and determination. So no idea is bad, and we should not be discouraged by that. This is the moral of the story, and we should be inspired by this man, Professor Jade, who was an Iranian mathematician and very fine gentleman. So rough set, another was rough set. It was given in 1982 by Paulak, and he instituted rough set theory to model the vagueness. And I'll show you. He made use of the equivalence relation. So equivalence relation is a relation you study in discrete mathematics. So that concept he has used here to define this set, and he defined the lower membership and upper membership, and lower approximation and upper approximation. This lower bar is lower approximation and this upper approximation. So lower approximation, he says that the elements belong to the set with certainty, and the universal set minus the upper approximation is the region where the element do not belong. That element does not belong to that region. It's out. Yeah. That means it's not belonging to the set. So that is out of the set. Okay. The region universal set minus the upper approximation is the region whose elements do not belong to the set. They are out of the set. And there is a region below within the lower approximation that all those elements belong to that set with certainty. Now the region left is upper approximation minus lower approximation. This is the boundary region. This is the boundary region in which there is uncertainty. The elements may belong to the set and may not belong to the set. That is the region of uncertainty where they will go. So this is defined in this way. So positive region is the lower approximation, and negative region is the universal set minus upper approximation, and the borderline region is the upper approximation minus lower approximation, and the elements belonging to this region, they might belong to the set and they might not belong to the set, or they partially belong to the set or partially do not belong to the set. That is what was the concept he brought out here. So if I say red balls and green balls, so and then I have red objects and green objects. So objects are circular and square. So when I take squares, so all the red and green squares will belong to the set. If I take circles, then all the red and green circles will belong to the, or balls will belong to the set. Oh, yes. Okay. Now there are some objects which are half red and half green. Where they will belong? So they belong to the red objects, or they belong to the green objects. So that is the uncertainty region. So some are partially red and partially green objects are then in which so all the objects which are green, they will belong to the set green objects. But there are some objects which are partially green and partially red. So they partially belong to the set and partially do not belong to the set. So they belong to this upper approximation minus lower approximation. They are on the borderline So how to deal with this? This is an undecidable area. We have to handle this. Where this is a challenge. Okay. Then wake sets were given by Gao and Burer in 1990s. He talked of support and against and hesitation. So he said that Jade talked about of the truth of the membership, but falseness of the membership. He didn't talk of that. So he took only one side. So here he said that there could be the other side also. The membership may be false or true. So truth of the membership and false also. So what is evidence in support and what evidence is against the membership and what evidence is in favor of the membership. So those two things are to be taken, and the difference left out is called hesitation. So I take example, there are 9 members in a committee, and the meeting can be held if there are 5 members present. So once a meeting was called and 5 members were present. So out of 5 members, 4 voted in favor of the resolution. So resolution was passed. But what about the remaining 4 who were absent? They did not vote. So if they had been present, what would have happened? So that difference 4 by 9. So 4 by 9 is support and 1 by 9 is against, and the remaining 4 by 9 is the hesitation region. That 4 by 9, if it goes against, then it will become 5 by 9 and this will be greater than this and resolution will not be passed. So this is the vague situation. And the sum of the memberships is less than equal to 1. So sum of support and against is less than equal to 1. So when it is less than 1, so 1 minus the remaining sum of these two will give you the hesitation area. So the formula is given here. So alpha is in favor and beta is against. Then alpha plus beta is less than equal to 1. Then 1 minus alpha plus beta is the vague index. That is the hesitation. That's what. So Gao and Burer introduced this thing in 1993 here. So he talked of true membership and false membership. Alpha is the true membership and beta is the false membership. And true membership plus false membership should be equal. If it is equal to 1, then it is a fuzzy set. But if this is not equal to 1, it is not a fuzzy set, it is a vague set. So what about the remaining part? 1 minus alpha plus beta. That's the vague index or hesitation. At the same time, Atasno gave has found these intuitionistic fuzzy sets, and he suggested generalization of fuzzy set as intuitionistic fuzzy sets, and he gave the concept here as membership, about the degree of membership and degree of non-membership. He talked in another way. The formula is same as that of the vague set, but his concept was different. He say, what is the degree of membership, then what is the degree of non-membership? And if the degree of membership and non-membership is 1, then it is a fuzzy set, simply fuzzy set. But if their sum is not equal to 1, then what will happen? So if the sum of membership and non-membership is not 1, then what will happen? 1 minus membership plus non-membership, that will give you the hesitancy index or intuitionistic index. So he talked about intuitionistic index or hesitancy index, and how much. So example is people in computer science, people hesitate to take the paper of theory of computation. It's tough. So hesitancy may be due to either the paper is tough or the teacher who is teaching theory of computation is not so much expert of that area that you can take that paper. So it's a level of difficulty or level of understanding. So many factors can be there which can lead to this hesitation. Okay. Then another concept which has come up fast is a soft set. And soft set is a new mathematical tool. So all the tools till now, which we have taken up, they we are dealing with the uncertainty based on the relationship among the elements of the set. But there may be some external parameters which have not been incorporated by these uncertainty handling tools like fuzzy sets, rough sets, and weak sets. So the external parameters can be there. So there can be relationship of elements of the set with the external parameters also. And none of these fuzzy set, rough set, and weak set models that relationship. So soft set was given to model this relationship. So in other words, this is useful in modeling the perception of the human being. Because when I'm making a set, I have my own perception. With what perception I'm creating a set. So that is my external influence on the set. So human thinking is granular in nature. And you have your own, so human thinking can be modeled by this soft set. So human thinking has a perception. Human thinking has its parameters. So soft set is a parameterized family of subsets of the universal set. So which parameter you view as important to create a set? It depends on you. So your perception. So soft set is able to model your perception because your perception will contain a parameter with respect to which you are going to divide the universal set into subsets. Okay. So uh, the soft sets are neighborhood systems here, and let's say take the uh, pair. So you have a pair FA, where A is a set of parameters and U is the universal set, and you are mapping the parameters to the elements of the set, and PU is the power set of the universal set. So power set is what? Power set is set of all subsets of the universal set, and you are mapping all those subsets of the universal set with the parameter. So you are arranging those with the your parameters. So parameters are coming from outside, or it can be coming from the human perception. So that is the important thing which was modeled by this Morstow. He gave this idea, very important idea, modeling the perception of the human beings, which has influence over all kinds of decision making. So let's take an example. You want to buy a good dress. Now, how do you define a good dress? A good dress for you may be a different, and for me may be different. You may like one color and I don't like that color. You like a black color, but I don't like a black color. So it depends. My perception is different. So if the dress is black, for you it is a good dress, but for me it is not a good dress. My perception is different. So perception depends on my culture, to which culture I belong to, and what are my cultural conditions. On the basis of that, I have a dress. So, a North Indian may like one kind of dress, and South Indian likes another kind of dress. So, the choice is different. Your perception is different. So, for a good dress, I will have parameters. So how you define a good dress, it depends on certain parameters. So for me, a good dress maybe first parameter is it should be economical. The second parameter will be it should be durable. The third parameter is it should be attractive. So I have three parameters. So when I go on the shop and I ask him to show me the dress, the shopkeeper is also a very intelligent person. He knows your psychology, and he will ask you in what range do you want. So you say I want a dress within 500. So that is fixed now. So all the subsets of the dresses available in the shop whose price is less than 500, he will select out those and start showing you. Then you say that no, I don't like this dress. I want a durable one. Then he will take another subset of it. So 500 and durable ones. He will start showing them. Then you will say, no, this is not attractive. You show me attractive one. I want bright colors, so on. So he starts showing bright colors out of it. So it is subset of this. Based on your criteria, that subset of will make your good dress. That is the decision which comes out from that. So that is a soft set. So soft set is mapping your parameters with the subsets of the universal set. That way, soft set can be used to. So I'll skip this slide because of shortage of time. Then a lot of algebra has been defined for the soft sets, inner product and all those things. I'll not go into the details of data mining. Basically, association rule mining requires to find the probability of A union B, and the conditional probability is confidence, and support is the probability that the two items are associated, A and B are associated. So it is the frequency of A union B upon n, total number of transactions. And confidence is A implies B, that if somebody buys A, he will also buy B, or item B is associated with A. That is the frequency of A union B. Both are sold together upon the number of items of A are sold. So that gives you the conditional probability. So these are the two formulas which you use in association rule mining, and in association you are interested in knowing which items sell together in association and so on. If somebody comes to buy milk, what is the possibility that he is also likely to buy bread and so on. So this is a knowledge. Association is a kind of knowledge which people are interested in, and we do association rule mining for that. So most of gave this offset, and I'll talk. Now the combinations of soft sets have come up with the uncertainty modeling tools, fuzzy soft set. So first I define a soft set. That means I define my set based on my parameters E1, E2. And then so my parameters are that the car is costly, metallic, color is metallic, and so on. These are my parameters. I choose these parameters. And based on these parameters, the cars which have this thing, I choose. Then I talk how much costly is the car. So my parameter is also fuzzy. So it is 50% costly, or 80% costly, or 90% costly. So what is the membership of costly? So my parameter becomes fuzzy. So when I make my parameters of the soft set fuzzy, it becomes fuzzy soft set. Then soft fuzzy set has been defined. First you define the fuzzy set. You define the memberships of the elements of the set. So membership is the relation among the elements of the set. And then you have an external influence of your uh, perception or your parameter. So relation of parameter with the fuzzy elements of the set. So then you arrange the fuzzy elements of your set according to your parameter. So map with your parameters. So based on your parameters you are taking up, that becomes a soft fuzzy set. Okay. So now I define some concepts. These are well-known concepts. T is a transaction where X is belong to set of items I. T bar is a transaction. Here I define a soft transaction where X is an element of item set I, and E is the parameter according which this item is selected. So E is a set of parameters E which you have, according to which you select this parameter. That is called a soft transaction. And fuzzy membership is this is a general function we have defined. Although the membership which is given by till date is based on the number of transactions and how many times item X is purchased in a transaction. So if tea and milk are if tea and sugar are bought together, so in a transaction, then the membership will be half. Sum of membership is always 1, so membership will be half. If 3 items are purchased in a transaction, so they are equally likely to be purchased, and their membership will be 1 by 3, 1 by 3, 1 by 3. This is the way we take fuzzy membership up till now. But we have given this fuzzy membership a function which is a weighted average. So I have a measure of my item and measure of the transaction. And the measure of the transaction is the sum of the measures of all the items purchased in a transaction. So the measure may be different than the number here. I'll show you the example of this just now. Then you have fuzzy transaction. You buy an item with some membership. What is the membership? Okay. Then you have a soft fuzzy transaction. You have the item X membership mu x, and it is arranged according to your parameter E. And fuzzy soft transaction is that item X with arranged with selected with your parameter E, and what is the membership of your parameter? How much, say I say costly, so how much costly? I say durable, so how much durable? 50% durable, 80% durable, and so on. So I'll take an example of fuzzy membership here. How our membership function works here, it is different from the membership functions which are being used most commonly. You have two items, tea and sugar, bought in a transaction. So the fuzzy membership on the basis of quantity. If somebody buys tea, 1 kg tea, he buys 4 kg of sugar. There is a ratio. So generally in transactions, you have number of items, and you divide each item by number of items. So if 3 items are bought in a transaction, the fuzzy membership is 1 by 3, 1 by 3, 1 by 3. But here no. I am buying 1 kilogram of tea and 4 kilogram of sugar, then what should be the weight? So measure of transaction tea is 1 and measure of transaction sugar is 4, and the measure of the whole transaction is 1 plus 4, 5 kg. So the membership of tea is 1 by 5th and membership of sugar is 4 by 5. So this is the basis. So my parameter is quantity or weight, then the membership will change. So, but if my parameter is price, I bought 1 kg tea and the cost is 200 rupees, and I bought 4 kg of sugar, sugar is 40 rupees per kg, then the membership has changed now. So money value transaction, so fuzzy membership based on money value will be different. So I have tea 1 kg at rate of 200 per kg and sugar 4 kg at rate of 40 rupees. So the money value of tea is 200 and money value of sugar is 160. And the money value of the total transaction is 360. So membership of tea is 200 by 360 and membership of sugar is 160 by 360. So this is the measure of the item and measure of the transaction. Measure of the transaction is total 1. So this is the way we take the various aspects into consideration to incorporate the fuzzy membership. So algorithms can be developed in this manner. Now this is an example of the item set association pattern. PI is the combination of these items, and you have fuzzy association, you have the pattern and the membership of the pattern. Soft association, the pattern selected based on the parameter, and soft fuzzy association is a pattern based on membership and based on the parameter, and so on. So in this way you can have many definitions. So I'm not going to details of this because you all know about association rule mining, and we determine the soft and support and confidence. So I'll take simple example of this here and show you that how the results have changed if we incorporate this soft set and fuzzy sets and various combinations. So how this is impacting the results in association rule mining. So this is the data given about the transactions T1, T2, T up to T15. There are 15 transactions, and you can calculate the frequency of each item in items here and divide by total number of transactions. That will give you the membership of that transaction or probability of that transaction or support of that transaction here. So you see here, now we put the minimum support to be 20%, our threshold, that we decide that if the support is greater than 20%, then we'll consider that transaction is frequent. So with this concept, we perform this mining. So Canada was found 41% times, USA was found 54% times, trade was found 23% times, acquisition was found to be 23 times in the data set of transactions. And then we find the frequency of two item sets which are frequent. So if their frequency is greater than 20%, they are frequent. So here we took this threshold, and for this we got this Canada is associated with trade, Canada is associated with acquisition in these two transactions, and the confidence was found to be 57.3%. Now, when I go for three item sets, Canada acquisition and trade, Canada trade and acquisition, these are the associations which have this confidence. So this was the simple, sorry, this was based on the soft set approach when I have my parameter here. So I'll compare the results. First, I use soft set and then I use soft fuzzy set and how it is differing. So USA and earn, this association in soft fuzzy set is missing, and in soft set it is giving 26% with 33% confidence. Now this is the over prediction of this pattern by simply soft set, which was proved by soft fuzzy set. That means the relationship among the elements was not taken into consideration here, and this gave us the false association rules. And this has been eliminated here by soft fuzzy set. So same way here it is giving, here it is not giving. So this is the case. I'll show you other cases also where it is showing here and it is not showing here. So we can remove the problem. So if a particular type of uncertainty is not incorporated, it leads to under prediction or over prediction of the patterns. And in whole soft computing, we are concerned with the prediction of the patterns basically, whether it is machine learning or whether it is neural networks or whether it is anything. Any other approach, data mining, anything, clustering or classification. We come across the issues of under prediction and over prediction if the uncertainty involved is not handled properly. That is the main idea behind this whole concept. So to overcome these problems of under prediction, over prediction, we have to work. So I'll give you a real data set study. We perform some fuzzy association rule mining. So it is data set we took from January 1st, January 2010 to 31st December 2011, 2 years data of Pune city of India. It is available on the Pollution Control Board of Pune website, and two areas of Pune were considered, Chinchwad and Karve Road, which were having 570 and 692 transactions in that data set. And there were three pollutants, SO2, NOx and RSPM. And the value of average amount of each data item per day is available on the website of Pune Pollution Control Board. So we considered below acceptable limit, above acceptable limit and area. So these pollutants are somewhere they are below acceptable limit, somewhere they are above acceptable limit. Area wise, we considered that data set, and areas we considered A1 and A2. A1 is Chinchwad and A2 is Karve Road. And A3 we took the sum of the two, both whole area. Now whole area will lead to average basically, and this will be misleading. You will see just now in the results that if I take all it, it may lead to misleading result. But if I go to the granular level, the results are something different. So that so when we take this here, you see if I use soft fuzzy approach, this says this pattern is not frequent and this says it is frequent. So soft set is simply soft set I'm using. That means I did not incorporate the relationship among the elements of the set. It is leading to over prediction. And when I have not taken into account the fuzzy membership, that is the relation among the elements of the set, this is leading to under prediction. So this is over prediction, this is under prediction, whereas making it soft fuzzy, it has improved. So this is how this is able to prune out the problem of under prediction and over prediction. This is a very important aspect in the soft computing, because when we deal with the soft computing or prediction of patterns, the major problem is over prediction and under prediction, which leads to wrong results. So these uncertainty handling tools can be used to overcome these issues here. So this is one important example which I have presented here. So I'll skip all this and I'll show you another slide. I'll put up another set of slides just now to overcome show you something on how neural networks we combine with neural networks this to. So one of my student has done MTech dissertation on swarm optimization based fuzzy and soft neural network models. She has developed here, and I'll show you just now. I'll share first. Okay, I have to share it. All right, I share this, and yeah. So this is a swarm optimization based fuzzy and soft set neural network model developed by my student Sana Akbar. She is now doing PhD in computer science at Manit only, and we have dealt with the relationship among the parameters using fuzzy set, among the elements of the set using a fuzzy set, and we have used a soft set to deal with the parameters, relationship of elements with the external parameters. And we have constructed a neural network model for that, and just to predict the secondary structure of protein. And we have also used some swarm optimization here. Uh, that's another concept. We follow the characteristics of the swarm, how they move together in colonies. Uh, that concept has been used because to reach the target, they follow a certain pattern, and so we tried many two patterns. One is swarm optimization, and second is one is particle swarm optimization, second is ant colony optimization. We tried to do work with both of them, and we found this PCO was found to be better result. We will see just now the result. So I'll not go into details of this biological background, because predicting the secondary structure of proteins is a great challenge today, and uh, so uh, great challenge due to a lot of uncertainty in the proteomic data is there among the relationships. There are many hidden relationships which we have not been able to uncover, and so we need various intelligent techniques to deal with the uncertainty and explore those relationships to predict the secondary structure of the protein. So till date, we do not have a highly accurate protein structure prediction tool. Although people claim high accuracy, but 75% accuracy is considered as gold in this area till date. So, why? Because you train your model with some data set and it works nicely on that data set, but when the new data set comes, it fails there somewhere. So every day new data is being generated through the experiments, and uh, so many of the relationships still are hidden, which have not been explored. So we have tried to use intelligence optimization here. So it is basically nature-inspired computing algorithm, and it's based on the population also. And there are two such. Uh, One is ant colony optimization, second is particle swarm optimization. And fuzzy set and soft set I have already explained you just now here. So swarm has a large number of homogeneous and simple agents. They interact locally among themselves, and then they interact with their environment, and then with no central control. So they don't have any central control, so and they allow the global interesting behavior. Then there is a ant colony optimization, which was given by this nature-inspired meta-heuristic solution for basically the combinatorial optimization problems. This was introduced by Dorigo and his colleagues, and this particle swarm was introduced by J. Kennedy in 1995. So you see here, so this was just for bird flocking swarm optimization. How that's the social behavior. So these based swarm intelligence algorithm, they provide the granularity and foresight to narrow down the search, preserving efficiency of the two approaches. So this is again the nature of ant colony, how they cluster together, and this is about the behavior of swarm, the birds, how they flock together. So this is the and how they narrow down to the particular target, searching that target. So this is about the ant colony, how the ants move here, and this is the point where they want to reach, and what is their movement. You can see here, uh, the movement is something like this. Okay, and so this is the behavior you observe in the, but in the PSO, this is the distance and how they flock to around it.
We cannot see your screen. It is not visible.
I have shared the screen here. I'm
Yes,
not able.
screen share is there, but document is not open, so it is not.
Okay. I'll
Please share it again.
I'll share it again. No problem. Now my screen is visible.
Yes, sir. We can see paper final and Sana MTech is visible. Yes.
Now
Sir, it is no. It is this document is not open.
I have opened the document. It's not open.
It is not open, sir.
How come this is happening now?
I think, sir, you need to reshare it.
I have to reshare it.
Stop sharing
Okay.
and then again share it.
Okay. That means there's a problem of some net. Okay. I'll reshare it. All right. I'll share again.
Now share them. Yes, sir.
Not visible.
No, sir. Again, document is not open.
Document is not opened.
That issue is there. I think PDF can be opened. This is PPT. I think.
I'll uh, first I'll open the document first. Okay.
Okay.
And then I'll share it.
Okay, sir.
I'll do it now. Okay, what I can do is upload here. All right.
Yes, sir.
I'll upload it here. Is there any
Now you
share
need to share it, sir.
optimize screen sharing for video clip? No, is there any advanced file I can upload here? Yeah, I can upload from the file here. Okay, files I can share. No, how can I upload advanced features? Portion of screen
I think
content.
there is some parameter in the PPT that is not allowing you to open it.
Okay, Microsoft SharePoint. No, there is a concept of There is one more there where I can upload the slides here itself.
Sir, you can upload it from chat option. Somebody is saying this.
Chat option. Okay, I'll go on the chat option. Chat. Okay. It is saying find participant. It's not showing chat. Okay. File. I'll upload the file. No problem. Applied. Apply. Okay. I can go on the.
No problem, sir. I think this was the last part, and if it is not opening, then if it is there is much more travel, then we can leave it, sir, for sure. We can discuss it without PPT. You can give information about that.
Okay. All right. Okay, I'll take up another PPT. No problem. I'll explain another one case. What concept I wanted to explain. I'll take up here. This is visible.
Yes, sir, this is visible.
Okay, I'll continue with this one. Okay, quickly, I'll go through. I'll give you another concept what I was talking. So here again, also we have used the combination of fuzzy and soft set based approaches with machine learning, and so this is basically the epitopes, and epitopes are the structures which we want to find for development of vaccines actually. So peptide based vaccines, we need the identification of epitopes in the uh, uh, proteome of the body. So their epitopes are basically antigenic determinants. And the data set is available regarding the epitopes uh, on various websites. Uh, and this data set, I'll skip all this here. And this all methods, you people know about them. Already I've discussed so there are various parameters which, and these are some of the softwares available for determination of epitopes, but their accuracy is very low. Their accuracies are also given here. This is the accuracies given here. So this motivated that we can further improve by using the uh, uncertainty handling tools. So the objective was to address the challenge of this accuracy and performance of the prediction of the epitopes in the data sets. So methodology here is all the data of 18 antigen antibody complexes. It was taken from the protein data bank, and there were 84 files there, and 50 files were used for training and 34 for testing. So we have made various parameters with there, which for which you have the scoring functions, and there are 20 amino acids in a protein sequence. So there is a software sharp by with which the score can be calculated. So values of the scoring for functions were taken up, and we labeled the training examples and use the machine learning algorithm, prediction rule, and you have a classification. So it's basically a classification problem. So here we have made use of support vector machine to for prediction of epitope. So this is a basic problem we started with developing a support vector machine model, and I'll quickly go through these are the 6 parameters which were taken up, and the training was done, and for support vector machine was uh, developed here, and we took the combinations of 2, 3, 4, or 5 parameters here, and all parameters, and then we use the RBF function, and we calculated the F scores, MCC values, all this area under the curve. So these were the values which were obtained. Highest accuracy of 60.3% was found by the support vector machine model. This was the basic model we started with. Then we tried to combine the soft set with the support vector machine for prediction of this epitope. I'll skip the methodology here. Mainly, we are combining the soft set, and we are introducing our parameter into it. So data set was trained using the soft set here, and you can see the same concept was used, and you see the different types of accuracy when we are taking 2 scoring functions or 2 parameters, when 3 parameters, 4 parameters, 5 parameters, and you see the accuracy have been increasing beyond 60%. So I'll come to, so the highest accuracy was found to be 61.3% with combination of 6 parameters, and F score has improved here, and AU's Matthews correlation has improved here. So you can see that soft support vector machine, we got 0.653 as area under the curve. This was better than the previous one. Okay. Now we try to make use of develop fuzzy support vector machine for this prediction of this epitope based on the data set. Same data set was used. Only thing is that we fuzzified the scores here. So all the scores were fuzzy membership was calculated for each scoring function and each patch which contains the epitope. And then the same training of support vector machine was done. Same steps were followed. And same combinations were used to prediction. And you can see the accuracy has improved. It goes beyond 80% for all combinations. So the maximum accuracy was found to be 83.21%. F score has improved, MCC value has improved, and you can see fuzzy SVM model, we got 93%, 0.933 area under the curve as compared to SVM model, which was 0.634. And then we have comparison of SVM with soft SVM. There's a marked change in the accuracy here. So it was fuzzy SVM, soft SVM, and SVM. This is a change. Now let's come to the combination of soft fuzzy now. We combine both. So when we made it a soft fuzzy model, and it was trained with the same data set, you see the accuracy has still improved. So soft fuzzy SVM and soft SVM, there's a big change here, big difference here. Then we talked of type 2 fuzzy sets. So I discussed only type 1 fuzzy set in the morning. But again, type 2 fuzzy set is like this, that it contains membership of membership. For example, if I'm going to buy the fruit, what is the possibility that I buy apple? So when I go to market to buy the fruit, 80% times I buy apple. Okay. So that is membership of apple is 80.8. All right. When I go to the market, mostly I buy apple, and whenever I buy apple, the quality of apple is above 80%, or quality of apple is good. So what is the possibility that quality of apple is good? So I have membership, say when I go to buy fruit in the market. So 80% times I buy apple, and 60% times the quality of apple is good. So membership of membership, 60% of 80%. That is the type 2 membership. So that way we tried to develop this model, and this gave us a very good result. So this is an improvement in the support vector machine. You will see the results. I'll quickly go through. Yeah. So it is giving 86% accuracy, much better than the previous one, 86.633 for the combinations involved in this two parameters here. And MCC was 0.73 here. So comparison, we give the comparison of all soft SVM, fuzzy SVM, soft fuzzy SVM model. You see how the things have changed, and the proposed approach, this type 2 fuzzy, simply type 2 fuzzy, gave us the best result. You can see here when I talk of the accuracy, this here. So that means the type 2 membership, and we have not tried the type 3 membership till date. You can go for type 3, type 4 fuzzy sets also. And we did not try soft type 2 and so on. This I will skip here because this was again totally another approach. I stopped sharing this slide. Only thing is I wanted to show you that those slides where we have used SOM optimization. Okay, I'll try to show you with the help of a research paper of my student. Okay, I'll try. It will take another 5 minutes, and I'll do it with that help of that only. Yeah, paper is also there. I think that, yeah. So I think now I can share the screen. Yeah, you can see the paper. It will be in the short, but this will give you the idea. So this is our paper, which with the help of which I'll try to explain you. So we tried two algorithms I was talking of here, model. So we have a computation framework we have proposed using the SWARM optimization and fuzzy set, and it is what fuzzy set and fuzzy neural network. Okay, simply fuzzy neural network based on SWARM optimization, but I'll not be able to cover the uh, soft fuzzy part here in this paper that was in that document which I was showing. So we use simple neural network first, and we have amino acid residues 1 to 20. There are 20 residues, and there are 13 residue records. We construct their values using this, and we try to create a fuzzy neural network, and then we create a balancing PSO, particle swarm clustering, before being put into the neural network. So whatever data sets we are giving here, we use particular swarm clustering of that data here, and then we feed into the neural network for training and testing of iterations. So this is a kind of pattern that is matching with the particle swarm optimization, how the swarms are flocking together. So that way, and the fuzzy membership is calculated by this formula: frequency of occurrence of secondary structure upon the length of the structure. So that way we took this here, and there were 6 standard data sets available on the net. These are the biological databases where these data sets are available, and these 6 data sets were used to train and test our algorithms here, and all of them have different levels of variations and different amount of this the length of the total residues here and number of sequences. All those things were varying. The size of the data set also varied for all these standard data sets. So we carried out all the 6 data sets available at that time, and you see here. So you can see the approaches of simple and fuzzy neural network both were explored using the swarm optimization here, and this is the different sensitivity levels we tried to perform this validation technique 90, 10, 80, 20, 70, 30, 60, 40, and so on. We try to do this thing here. So this where the accuracy is recorded for validation of 6 data sets. So this is the level of accuracy when we take 10 cross validation, then this is the color. When we go for 20 cross validation, this is the level of accuracy. We go for 30 cross validation, this is the level of accuracy. And we go for 40 cross validation, we have this accuracy. So this is giving the best results you can see from here for all some of the data sets. But for other data sets, this is giving better. So I think this one will be 3070 is much better choice here in because this is giving low accuracy in this standard data set, but not here. So now the accuracy is recorded for each of these data is shown in these tables. So for different data sets, we got these levels of accuracy, and these were found to be the best accuracies for different standard data sets. And then we have performed the sensitivity analysis of the data sets, and for all these data sets you find here, which is giving the best one, 70 to 70-30 simple and 70-30 fuzzy. So fuzzy is giving us the better results here in this whole set. You can see in all the results we get here. So 30-70 simple fuzzy is giving the best accuracy. For the 30-70 is giving the best accuracy for this data set, for this data set. This data set is again fuzzy with 30 cross validation. So people generally use 10 cross validation. We got best with the 30 cross validation results here. So these are the available accuracies here of the existing tools for prediction of these structures, but we got this as 97% here. This was the best one here. And this is the confusion matrix available for the neural. So performance. So proposed fuzzy PSO based fuzzy neural network model was the best, giving us the 97% accuracy, which is highest accuracy above which is available. Existing accuracy is between 70 to 77%, and we are getting 97% out of this. So this was the our results here. So most of the work is based on this, and we have combined soft sets also, soft fuzzy, fuzzy soft, fuzzy soft fuzzy also we have done in this area with the neural networks and PSO and ant colony. Among ant colony and PSO gives the best result. This is what is observed by us in our whole of the work. So with this I conclude that different kinds of uncertainty, whether you are developing neural network model or support vector machine or clustering or classification, the various combinations can be explored of these uncertainty modeling tools with them to improve the accuracy performance of the algorithms. And SoftSet is having a great promise today because SoftSet is able to model the perception, that is the external impact of external parameters on the relationships. That is very important. So I end the talk with the words that if a person is watching an object and he says that the object is beautiful, but the object may not be beautiful. It is the beauty lies in the eyes of the person who is watching the object. This is soft set. So soft set models perception. Soft set models the granular thinking of the human beings, and that can be introduced into all these with other uncertainty handling tools with in combination with other uncertainty handling tools to develop more better algorithms for prediction and determination of classes, clusters, or association pattern, and all improve the soft computing techniques. So with this, I thank you all for patient listening. If you have any questions, you're most welcome.
Thank you, sir. Thank you very much for sharing your knowledge and time. Sir, I am Dr. Fatima, who
Yes.
called up you. Thank you.
Okay. Thank you. Thank you.
Sir, my HOD ma'am also want to talk with you. She is coming in a minute. Please wait, sir. Don't leave. Sir, your lecture is very good. You have done lots of
Thank
work
you.
on fuzzy,
Thank
neural,
you.
and all type of soft computing.
Actually, it was the requirement. And when we deal with the biology, we come across data sets, and again, it's the requirement. So that made us to do it,
Yes.
to explore it. So when we come across the challenges, you learn a lot from that. Okay. Good morning, madam. Good morning.
Good morning. Sir,
Yeah.
good morning.
Good
Thank
morning.
you, sir. Sir, thanks for sharing your views on computational techniques. Sir,
Thank you.
actually, sir, I was busy somewhere else. So that's
Okay.
why I was not able to welcome you at the time.
No, no problem.
So sorry for that, sir. But
It was
thanks
nice.
for sharing your views. Thank you very much.
Okay. Thank you. Thank you. Nice to meet you. Thank you.
Thank you, sir. Nice.
Okay. Thank you very much.
अभी उमंग करेंगे
Okay, sir. Thank you, sir. Thank you.
Okay. Thank you. Okay. Thank you very much.
Okay, sir. Participants, now our next session will be taken by Umang Kejriwal, sir. So now we'll start with this lecture today. Yes, feedback link will be posted here in few minutes.
Okay. Okay. Good afternoon, all participants. So I hope you all are okay. You are fine today. So today we will discuss about natural language processing, and in this one we are going to discuss about sentiment analysis. Okay. How to find out the sentiments behind a statement or a word using natural language processing. So this thing we are going to learn today. Okay. So before wasting the time, let us start a new file. Create a new file. In the Google Colab. Just a minute. Where's the chat option? Okay. Yeah. Okay. So I'll give the file name as SIRT sentiment analysis. Okay. So basically, what is sentiment analysis? Anybody can tell me what is sentiment analysis? Any example of sentiment analysis? Anybody? Opinion mining. Okay. See, basically, if you take an example of review, we write reviews on Amazon, on some website, like some product review, or you can take an example of the movies review that we write on Book My Show. Any website we write reviews, right? So suppose there are so many reviews, and the company has to find out that whether the review of the product is a good review, that means a positive review, negative review, or a neutral review. So if he has to find out, he has to read the review and then he has to find out. So reading so many reviews by a simple human being, it's very difficult. If I have 1 lakh views and I have to read all the view and analyze, it's very difficult in that case, right? So in that case, what we can do, we can apply the algorithm, some you can say some techniques of sentiment analysis through which we can analyze the sentiment, whether that is a positive, negative, or neutral. Like if you remember, we have scrapped the reviews of Amazon website on second day, I guess. Second day, we have scrapped the data, right? So we got near about 3,000 reviews. And now I want to analyze that whether that is positive, negative, or neutral. So we can do with the help of this. So sentiment analysis can be done by a library that is inside the NLTK. NLTK stands for Natural Language Toolkit. And that is a part of NLP. That's a part of actually NLP. Okay. So first of all, we will import that library. Okay. And then we will, first of all, analyze some words, some simple word, good, bad, worst, like this. And then we will move on to the statement part. And then I will tell you, we will consider one data set. And in that data set, we will analyze the review. So this thing we are going to do right now. Okay. So I'll import the library. Import NLTK. Now, in this NLTK, there is one package with the name Vader Lexicon. Vader Lexicon, which is developed by the Facebook company to apply sentiment analysis. Applied by the Facebook company to apply sentiment analysis. So we will import that Vader library from the NLTK. So I will write here from NLTK dot download, and here you will pass Vader underscore lexicon. Vader underscore lexicon. It will take some time. Yeah, it's downloaded now. We got the true message. That means it's imported. Now, in this package, we have one function that is called sentiment intensity analyzer. So we will import that for applying the sentiment analysis. So I'll write here from NLTK dot sentiment dot Vader import sentiment intensity analyzer. Okay, and in that you have to create an object for this. Let's create an object with a name SIA and execute this. So here basically we have imported the function sentiment intensity analyzer, and then we have created the object for this sentiment intensity analyzer. And now let us analyze the word. I'll write here SIA dot polarity score. So this polarity score gives you the score of the sentiment, and whether that is, with the help of this, we can know whether the word or statement or any text is a positive, negative, or neutral. So basically, it returns a dictionary. It returns a dictionary in which there will be 4 elements. So I will discuss that. So first of all, let us pass some word like I present here good. I have written here good. So if I write here good, and if I execute this, you can see I'm getting some 4 parameters. The first parameter is the compound. Second parameter is the negative. Third parameter is the neutral. and the fourth parameter is the positive. These four values are given by this polarity score, and this is a dictionary data. So basically, when we have to analyze whether a review is a positive or a negative review, then we have to analyze with the compound parameter. And the sum of negative, neutral, and positive will always be equal to 1. If there are some neutral words also in the statement, then there will be some value for neutral also and some value for positive also. And if there is a combination of neutral and negative word, then we will get some value here and here. I'll show you. Okay. So here it is completely positive. That's why it is giving the positive as 1.0. Okay. And now what is the use of compound? It is like you can say the weightage of a positive value or negative value or neutral value. Like suppose if I'm writing good, so anything can be more better than good. Na? We can write best. We can write very good. So that will be more good, more positive. So to analyze that, which is more positive, if we have to compare between two things, then we can compare by compound. If the compound value is more near to +1, so we can say that it is more positive. And if it is more near to -1, then we can say it is more negative. So the compound value lies between -1 to 1. And if the compound value is equal to 0, we can say that the statement is a neutral statement, or a word is a neutral word. And these words are actually defined as per the dictionary. If we have some word that is not in the English dictionary, then it will consider that word as a neutral word. Okay, because they have developed the library according to the English dictionary. So if we pass any other word that he don't understand, then it will simply consider that as a neutral word. Okay. So now let me give you another example. Suppose if I'm writing here, very good. Now you can see the compound value has increased from 0.44 to 0.49. But here we got a neutral value also, because very word is a neutral word. It can be positive also, it can be negative also, right? It can be very good, it can be very bad. So it's a neutral word. That's why some part of neutral also is given here. So if you add these two values, it will be 1. If you write here, very, very good. See, the compound value increased more and the neutral value also increased more, because we have increased two neutral values. That's why that's how the parameters will change. Now let us give a more better, like suppose if I'm giving here best. See, okay, right here, best and awesome. See, it's more negative, more positive. So that's how you analyze a word or a statement. You can pass a statement also. Okay. Now let us try to do with a negative word also. Please explain what. Sri Ganesh, compound is like a weightage. Suppose I am asking the library that there is a word good. Okay, good and very good. Now it will say that both are positive. Both are positive response. Both are positive reviews. But if I ask that which is more positive, then we will see that the compound value, the value whose compound value is more, that is more positive. So if the compound value is greater than 0, we consider that as a positive review. And if the compound value is less than 0, we consider that as a negative one. And if it is equal to 0, then it's a neutral one. So with the help of compound only, we analyze whether a statement or a word is a positive statement, negative statement, or a neutral statement. Am I clear? Neutral means no meaning. Like, see, if I write my name, so my name is not a good word or a bad word. So that's neutral. See, now in this case, the neutral value is 1.0 and compound value is completely 0. That's a neutral. If there is no word, if there is no meaning where it is good or bad. Okay. Now if I write here, not good. See, now we are getting a negative value. See, because it's a negative word. It's a negative statement. Worst. See, more negative. See, and you can pass a statement also. Let us pass a statement. The movie was the best and entertaining let's write here. This was the best and entertaining movie of my life. Okay. See, we are getting positive. It's a positive word. Let's write a negative statement. This movie was totally waste of time and money. See, I'm getting a negative sentiment. It's a negative. So am I clear how to check the sentiment? Tell me. Yeah, okay. Now we will, first of all, complete this, all of you, try this, all of you, and then I will share the data set on which we will work. Please do it, all of you. Let me share the link of this file. Sorry, I've sent privately. That's the link. Done? Yeah, can we continue? Okay, fine. So now I'm going to share one data set with you. See, this is our TSV file, tab separated value. Okay. And this contains Amazon reviews, near about 3,000 reviews it contains. So I'll tell you about this data set. First of all, let me share this file with you. Yeah, you can take it from the chat. All of you, please download from the chat and then upload it here. Upload that file here. Import pandas as PD and data is equal to pd dot read underscore csv. I'll pass here Amazon underscore reviews dot tsv. Now, as this is a tsv file, so we cannot write only this because we are using a csv function and there is no separate tsv function for this. Okay. So I have to include one more parameter, that is separated by /t. That means it's a tab separated file. And data dot head. Yes, so that's the data set I have shared with you. So please, all of you, get this data and then tell me, then I will continue. Yeah, done all of you? Okay, now see, there are two columns here. The first column is the label and the second column is the review. So this is actually the reviews written by some, we can say some users, some buyers. Okay. And this label is actually what? This label is some positive and negative given by the some human. So what we are going to do right now, we are going to analyze this review with our library, with this sentiment, this polarity score, and then we will compare that whether this one is matching with the data that we are getting with the library or not. So this is actual review, this is actual sentiment, and then we are going to predict the sentiment using our function, and then we will compare. Okay. So if you see the data.info, so there are total 2,984 data here. Approximately 3,000 reviews we are having. Okay. And data of label dot value underscore counts. There are total 1,574 negative reviews and 1,410 positive reviews. There is no neutral review here. All are defined as positive or negative. Am I clear? Tell me. So, review file again in the chat. Okay. Send the file. See. It's going on. So here I was saying that there are total 1,574 negative reviews and 1,410 positive reviews in our data set. Negative and positive here. Okay. So now we are going to analyze. So for analyze, we need this one. We have to analyze this one by one. So what I'm going to do is I'm going to add one column. I'm going to add one column in this, in which I will be storing this data for each row. For each row. Now see, if I have to get the text of this row, how can I get the text of this row? So I have to write here data dot iloc. Iloc is used to get the data row by row. Iloc function. Okay. And here you will pass the row number. Let's suppose I want the get data of row number 0. That means this one. Okay. So if you execute this, see, you are getting label positive and you are getting the review. But if I need only review, I have to write here. Now they see label is 0 index and review is 1 index. So if you write here 1, it will give you only the reviews. See, that's the review. Okay. So this is what I have to pass in the polarity score for each row one by one. So as I have to pass for each row one by one, I have to use a loop because there are many rows. So for I in, okay, for I in range, okay, you can pass here length of data. The loop will start from starting 0 and end till the last row. And here I will write, let's suppose I'm writing here text is equal to now tell me all of you where I will write I here. Should I write here I here, or I have to write here I here? Tell me, where I have to write I? In place of 0 or in place of 1? In place of 0, correct. Data.head simply prints the first 5 rows of the data. That's all. That's the meaning of data.head. Okay. It prints the first 5 rows, and data.info gives the complete detail about the data. See, they are totally this much entries. They are total 2 columns. These are the column name. These are the count of the non-null data in these columns. These are the data type of this column. That's all. Okay. Now, so this is a text that I will be getting one by one. Okay. Now I will write here score. Score is equal to SIA dot polarity scores, and here I will pass text. Now let's define one blank list here. Okay. Now polarity score dot append, and here I will pass score. So one by one, I'm appending the polarity score of each row in this list. In this list. So let's execute this. Done. Now if I print polarity score, you can see I get the polarity of all the rows. So now let's add this into our data frame. So data of polarity, you can take score, is equal to polarity score. Now let's print data.head. So you can see I got the polarity here. Okay. Now please complete this part, and then I will move further. Complete this part. Completed. Yeah. Can we continue? Okay, fine. So now I'll continue now. I think you have done. Okay. Now what I will do is, now I'll add one more column in which I will be storing only the compound value, only compound value. Okay. Now, as we all know that this is a dictionary. So suppose I want to get the compound value of first row. So how can I get? Data dot ilog of 0. So 0 will give me the all details, but I want only score. So I can write here either score, or you can write here 2 also. Okay, they both are the same thing. See, so now I want compound value only. So I can write here compound. Sorry, C is small. See, it is giving you the compound value. Okay, so let's do it. Compound is equal to blank list. So here C is equal to this. Okay, and compound dot append C, and here in place of 0 I will pass here I. Okay. Yeah, that's all. So let's execute this. Now data of compound is equal to compound data dot head. So can see I got here compound value. Okay. So do this now. Do this. Now what we will do, we will just compare this value. If this is greater than 0, then it is positive, and if it is less than 0, it's negative. So can we do this? Please tell me yes or no if you are doing, then I will wait for some time. Otherwise, I will just continue. Tell me. Wait. Okay, okay, okay. Complete and then tell me. Completed. Okay. Now let's compare the compound value and let's calculate the sentiment. Okay. I'll write here if S is greater than equal to 0, S dot append, sorry, just wait. S dot append positive, else S dot append negative. So now just tell me, all of you, is this thing correct or there is some mistake in this? Yeah, tell me. Is this thing correct or there is some mistake? This is sentiment. That thing I have changed. Other than that, is it correct or there is some mistake? Negative should be less than 0. So greater than equal to 0 is positive. So obviously we are left with less than 0 only. Na? So that's the else part. Yeah, tell me, what is the mistake in this? What's the mistake? Tell me. Zero is neutral. See, Silpa, you are correct. But in our data set, if you see, I've shown you that we don't have a neutral data. If you see here, where I've shown that, yeah, here. If you see here that we don't have a neutral data, so let us consider the neutral as a positive. That is okay. See, the mistake is what I'm telling you. What I told that in the last, I will compare the value. Sorry, I just told you na, that we will compare this value with my predicted value. So tell me, can I compare pos with positive? Can we compare this? Yeah, we can compare. Tell me, all of you, is this comparison can be done? Will it give me true result? No, na. How you can compare this? How you are saying yes? It should be pos here. It should be any G here. That's a mistake. Got my point? So whatever the data we have, you have to pass the same thing, then only you can compare. Okay. Now let's execute this. Sorry, why I've written here S dot append. Sorry. Yeah. So see. Okay. So now we got the predicted sentiment. So this is my prediction result and this is my actual result. Okay. So now we'll compare this whether this is correct or not. So first of all, complete this all of you and then we'll compare. Crucian, acha, okay, sorry. Let me disconnect the charger. What's happening? Yeah, done all of you? Okay. Now to compare this, now how to compare this now? Either you can use confusion matrix to find out how many comparison is correct and how many comparison is wrong, or you can use the simple for loop. So first of all, let us use the for loop and compare. Okay. So what I will write here? Let's suppose I am giving a variable as count is equal to correct, count is equal to this. For I in range if yeah, let us take a two variables first. Okay. So let us take y is equal to, y is my actual data. Okay. So data dot I log of 0, sorry, I of label. That means I am taking the data of the label column here, this column. Okay. Now in the YP, sorry, in the YP, I will take the data of the predicted column. Sentiment. Now if y is equal to YP, if this is equal, then let's define it as 0. That will be more better. 0. Okay. Correct count plus 1. Okay. That's a count of the correct prediction. And if you see the wrong count, length of data minus correct count. That's a wrong count. If you calculate the accuracy, that's accuracy, 70%. And see, in this text one, we cannot get more accuracy because we generally write reviews in short form. Like we generally write good in GUD, right? We use similes, we use short words. So that similes, that short words is considered as neutral. Okay, so that's the problem. So that 70% is good. If you are getting 70-80%, that is good. This noise is coming. So after completing, please tell me, okay? Due to some background noise, I'm muting myself. So please tell me after completing. Yeah, done all of you? Okay, last line. Okay, okay. Why these are making noise? Okay, now the same thing you can do with the confusion matrix also, which will give you more better data. You can write here from sklearn dot matrix import confusion matrix. So here I will write data of label, okay, and comma. I'll tell you. Data of sentiment. Data of label, comma, data of sentiment. Now see. So that's our confusion matrix. Now let me explain you about confusion matrix. I have given some idea about this yesterday also in that I think no, not in this. We have not covered the machine learning part, no? Okay. Some other. Yeah, I'll tell you now. Actually, I have given in the other batch. Okay. Just a minute. Why the chat is not open? Just a minute. So see, this is basically used for classification problem only. Classification problem. It is only used for classification problem, not for regression problem. Classification problem where we have some class, like here we have positive and negative, two class. Okay. Then it is always a square matrix. And the size of the square matrix will depend on the number of class. So if we have two class, that means positive, negative, so that means it will be 2 cross 2 matrix. 3 class, 3 cross 3 matrix. Okay, similarly like this. Okay. Now why it is used? Through this you can get the information about number of wrong or correct prediction. And you can also know that what it has predicted, what is the wrong prediction actually. Okay. So this is about a confusion matrix. So now actually how basically it calculates. So now let me explain you that. So for explaining you this, I'll give you a simple example. Let us suppose we have a marks of student, okay? And we have another column that is grade. These two columns I am having right now, okay? So this is my actual grade that is present in my data. And now let's suppose I have to predict the grade also according to the marks. So this is the predicted grade. Okay, so that's present in my data. Now, just a minute to look it better. Let me draw a line. Okay. Okay, so let's suppose I have taken this. Now let me take some random values. Like suppose I am taking here 90, 70, 35, 20, 100, 80, 40, 25, and 87. So I've taken this number of data, okay? Let's take it as 27, okay? So this thing I have taken right now. Now here I'll take A grade, A, B, B, A, B, 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 okay? So that's my actual grade. Now the predicted grade is, suppose this is A, this is B, A, B, A, A, B, B. Now that's my predicted grade. So this is your actual result and this is the predicted result. Now suppose I want the confusion matrix for this data. So obviously I told you that this will be 2 cross 2 matrix. Okay. So now just tell me one thing. If I take here grade, total samples, total correct prediction, and total wrong prediction. So if I ask you, just tell me, what is the total number of samples whose grade is A in the actual grade? Tell me. How many A is there? 4. And B is 5. Okay, that's correct. Now, how many prediction for A is correct? Now see, this is correct. This is wrong. Correct. Correct. So how many predictions are correct? 3 prediction. And 1 prediction is wrong. Okay. Now let's count for B. Correct, wrong, correct, wrong, correct, correct. That means 1, 2, 3. 3 correct prediction, and 2 wrong prediction. Tell me, is this table clear to all? Is this table clear to all? Okay. So the confusion, if this table is clear, then you can easily plot a confusion matrix. So the confusion matrix for this one will be now see, this is the position of actual, and this is the let me take it remove this. And this is the position of predicted. So here it will be A, B, A, B. Okay. And the sequence of this A and B will be always ascending order. Let's suppose my class name is true and false. So false will be coming here and true will be coming here. It should be in ascending order, in alphabetical order. Am I clear, all of you? So what will be this position called? Can we say that this is A? What is this? This is AB. This is BA. And this is BB. Right? So this means that A is predicted as A only. Okay? A is predicted as B. B is predicted as A. And B is predicted as B. So which position is the position of correct prediction? Tell me. Which position is the position of correct prediction? A and BB, correct. That means the diagonal position. Can we say that diagonal position? Yeah. So that's my correct prediction, right? And all other position are wrong prediction. Right? So now if I fill the detail, so now tell me what I will fill in the first row here. What will be AA? Three, correct. What will be AB? 1. What will be BA? BA will be 3. B is predicted as A. 2 na? And this will be 3. Right? Tell me, am I correct? So that is only your confusion matrix. Is confusion matrix clear to everyone? So if I want to calculate the accuracy from this, how can I calculate? AA plus BB divided by AA plus BB plus BA plus AB. Tell me, am I correct? That means 3 plus 3 divided by 1 plus 3 plus 2 plus 3. That will be 6 divided by 10. That's 60%. Tell me, am I correct? So this is only your confusion matrix. Now let me tell you about some term that is very famous in confusion matrix in case of two two class. Whenever we have a two class in the form of true or false. And that terms are very much famous in the medical field. In the reports, we generally hear that term by doctors. True positive, true negative, false positive, and false negative. Okay. So now, what is this true positive, true negative? Have you heard about this term? Tell me. No. No one has heard. Okay, no problem. Okay, Isa is heard. Okay. So I'll explain you by giving an example of a medical only. Let's suppose, let's take a current scenario. Let's take a scenario of a COVID. Okay. Now there is a one patient who who is having some symptoms of COVID. Okay. Who is having some symptoms, and he is now going to doctor, and doctor told to have the test. Okay. So when he had the test, then there can be 4 chance. There can be 4 chance. What can be the 4 chance? That he is actually having COVID. He's actually having COVID. That means he's actually affected with COVID. And in the report, it is also saying that it is the person is having COVID. Am I clear, all of you? This is the report, and this is the actual. You can say that I'm actually having fever, and the report also it is showing that it is I'm having fever. You can take like that. Okay. Now, second scene, I'm actually having fever, but in the report it is saying that no fever or no COVID positive. Then a patient can have COVID. Sorry. No COVID. Okay. And in the report also it is saying that no COVID. And here having COVID, but in the report it is saying that, sorry, not having COVID, but in the report it is saying that it is having a COVID. Which one is more dangerous here? The more dangerous is this one, right? He's actually having COVID, but according to report, he is not having COVID, so he will. No is also that correct. I'm asking about the funny one and the dangerous one. Okay. So these are the 4 scenarios. Okay. So this one is called as true positive. This one is called as true positive. The last one is no. What last one is no? Correct, na? I have already taken here no. Actually, you're talking about sequence. Ignore the sequence. Okay. So this is true positive. This is true negative. True negative. Okay. Then what is this called? False negative. And this is false positive. Okay. True positive means he is positive and it's true. True negative, he is negative and it's true. Right? False negative means he is showing negative, but it is false. It is not actually negative. Okay. And false positive, he is positive, but it's not true. It's false. That's about these four terms. Am I clear, all of you? Tell me. So, if I consider our confusion matrix, now let us take our confusion matrix. This. Okay. If I consider this matrix, so tell me what will be this position. Let us take 832. What will be this? This positive or negative? Tell me. The first row, this one here. Positive or negative? Positive. If you arrange positive and negative in ascending order, which will come first? N or P? N, na? So what it will be? It will be negative, na? This is positive. Positive, okay? So, out of, if I talk about negative sample, out of 832 plus 742, that is how much? Out of 1574 samples, out of 1574 samples, how many predictions are correct? Anybody can tell me? How many predictions are correct? Yeah, 832. That means negative is predicted as negative only. Okay. And 732 prediction are, so and 742 prediction are wrong. Now, if I take about positive, out of 1410 sample, 128 prediction are predicted wrong and 1282 prediction are predicted correct. That means this 128 predictions are predicted as negative. So in our array, which one will be the true positive? Tell me. What is this position? True negative, true positive, false negative, false positive. Tell me. What is this? Yeah. True negative, correct. It's true negative. This is true positive. Now what is this here? False positive, na? Here, no, yes. So no means negative and positive. Okay. And this is false negative. Am I clear? See, I'll tell you. You want, what is this? This is negative, negative. This is negative, positive. This is positive, negative. And this is positive, positive. Okay? Clear? So this was all about the confusion matrix. So am I clear, all of you? Tell me. So I hope the confusion matrix is clear to everyone now. Tell me. Okay. Okay, so now let us calculate the accuracy from a function. I can write here accuracy score. So that's the accuracy. See, we are getting the same accuracy. Okay. So this was all about the confusion matrix using, sentiment analysis using natural language processing. Now you all can do, like, if you remember, we have scrapped the Amazon data on second day, I think second day or first day. Okay. So you can now analyze the sentiment of that data. Tell me, all of you, can you do that? Can you analyze the sentiment of that? Yeah. That the data set that we have scrapped on that day, on the day when I taught you web scrapping, on that day I taught you, so we have scrapped some data. If I can show you. This one. So you can use this column, the fourth column, and you can analyze the review. Tell me. I hope you can do it, right? Please respond yes, no. Okay. So now if you have any doubts regarding this, whatever I discussed, you can ask me. Not perfect in coding. I saw there you should not be perfect in coding. Just you have to use what we have used right now. In place of this data set that we have used right now, you have to use that data set. That's all. No change. Just you have to import that data set and you have to use it. Am I clear? Okay. In that one, you do not have to calculate confusion matrix because we don't have the actual data there, no actual review. Just you have to analyze and find out the sentiment. That's all. Okay. So I hope you all enjoyed this session, and my complete session you all enjoyed and understood. I tried my best to explain you in more better and a more simple way. So I hope you all enjoyed this. So today is the last day, my last day for the training. Yeah, thank you so much. Yeah, thank you everyone. Thank you everyone. And I'm sharing the link of this file. You can download the code from here, from this file. Okay. Yeah. That's great. Thank you so much, everyone. Thank you. So anything you have to ask, any doubt regarding any day that I have taken, any doubt, any topic? No, Silpa, you cannot modify that library because that is a third party. Someone has made it. You cannot modify that. But you can create your own library similar to that. If you have some deep knowledge of Python, then you can create that. Okay. Yeah, any doubt? Tell me now, any doubts? Let me see the chats. No. Acha, do you need this file? Should I share this file also in the chat? Where is that file gone? This one? Do you need this? Okay, wait, I'll share it. Okay, so I'll share this image with you. Okay. You can check the chat. I have shared on the chat. Yeah. So, any doubt? I don't think you have any doubts now. So, ma'am, that's all for my side now.
Thank you, ma'am. Thank you so much. Thank you for sharing your valuable knowledge. Thank you, ma'am.
Okay, so should I leave, ma'am?
Yeah, you can leave. Thank you so
Okay.
much.
Okay, bye all of you. Take care and
Bye,
have a
ma'am.
nice evening, all of you. So it was nice taking session for you, ma'am, college. So thank you so much for giving me this opportunity to share this knowledge on your side. Okay.
Thank you, ma'am. Thank you so much. Your session was really very good, very awesome. Thank you so much.
Okay, ma'am.
Bye.
Thank you.
Bye, Uma.
Bye. Bye.
Participants, tomorrow we will resume the session at 11:30 on the same time. All of you, bye. Take care.